Hi, I'm Paul. We're doing Leetcode, must-know interview questions. Today's challenge, substring with concatenation of all words. And it is rated as hard. And it is hard. It's hard enough that I can't really sketch out the algorithm. I mean, I could sketch out the algorithm, but I don't think I can sketch out the algorithm, in the limited space that we have here. But it's okay. I think we can talk through it in an understandable way. So here's the challenge. We're given a string S and an array of strings, words. Those are the two inputs. All the strings of words are of the same length. Okay? Well, that's a good thing. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. They have an example here of a words array and then the different permutations that you could form from it. All right, we are supposed to return an array of the starting indices of all the concatenated substrings in S. You can return the answer in any order. Let's see. Let's take a look at a couple of examples here. So, foo and bar. All right, well, we can concatenate those as bar foo, and there's one instance of it there at index 0, and then at index 9 there is another instance concatenated as foo bar. All right, example 2. It is possible that there will be no concatenated substring. It's also good to know here that words can appear more than once in the array. All right, this one is bar, foo, the. Well, again, there's even with just three words, there would be 6 possible permutations of those words. So a bad way to do this would be to compute all the permutations and then look for them. That would be what we call computationally expensive. But anyway, 6, 9, and 12, so we have foo, bar, the, that works. We have bar, the, foo, that works. We have the, foo, bar, that works. All right, let's look at the constraints. The string length can be up to 10 to the 4th, 10,000 characters. The length of the words array can be up to 5,000. I assume that means the number of elements, but yeah, you definitely don't want to compute all the permutations of 5,000 elements. The length of each word can be up to 30, and it's all lowercase English letters. All right, so let's think about how we might do this. We're going to need a hash map, first of all. We're going to use a hash map, and we're going to store all of the words in the input array in the hash map, along with a count of how many times they appear in the input array. We are going to use a sliding window, and the width of that window will be the length of the combined words in the input array. Let's take an example here. So example 3. We have three three-letter words, so our sliding window is going to have a width of 9. Every time that we slide the window, and we're going to slide the window to the left one at a time, one character at a time, every time we do that, we're going to have to clone the hash map because, we want to be able to start fresh with the words and their original counts. All right. We're going to have another, what you might call a sliding window within the original sliding window. And that sliding window, we are going to slide that in increments of whatever the word length is. Okay, so we'll look at the first word, and if the word is in the hash map and the count is greater than 0, we'll decrement the count and we'll slide to the next word. If it's not in the hash map or the count is 0, then the current window that we're using is not going to work. We'll move to the next window. If we can slide through the entire window, one word at a time, we hit every word and there are no words left over, that's a win. So we keep track of that index. And at the end, we return the indices as a list. Okay, now let's see what the code looks like. All right, I have to admit at this point that I coded this and ran it and it timed out. And then I coded it again. I changed it a little bit, the main change being that I didn't clone the original hash map every time the window moved. And it passed, but the time was so bad that I want to try it one more time and see if I can do better. So it's not going to look as much like the discussion, but I don't know. We'll see. I mean, the way you can code it the way the way I initially described it and get it to pass, but time was really bad. So anyway, we are going to have a hash map. We have to have a hash map. New hash map. So we'll create that and then load it. We'll say for each word in words. Whoops. Needs a curly bracket. Word count dot let's say merge word 1 integer sum. What is that doing? Well, the merge will take a key, in this case word, add it to the hash map with the value provided. If it is already in the hash map, then it'll use the function provided as the third argument, meaning if the word is already in there, it'll just add one to it. All right. Now we need some variables here. So let's do string length is the length of the input string. Let's do num of words is the number of words. So that's the input array. The word length, they're all the same. Whoops, that needs to be int. they're all the same length, so we can just use words. Use the first one, and it's a method because that's a string. What else? Oh, we need a list to return. All right. So now we can, let's see, word length. We can iterate over the string. So let's do that. Whoops, for int I equals 0. I less than word length I plus plus. Doing this part differently. It's kind of a combination like sliding window and two-pointer approach. But let's get another map. Actually, let me just copy this one. Map string integer. Let's call this current count. And two pointers, int left and right. We're going to keep track of the total words at the end. If total words equals num of words right here, if the total words equals num of words, then that means we used all the words, and that is a win. All right, total words initially, 0. All right, we're going to start expanding the window to the right and add words into the current window count. So while right plus word length is less than the string length, I'll keep it within the bounds of the string. String sub for substring equals s dot substring right plus word length. We're going to peel off a word a word length word. Doesn't make sense. We're going to peel off a word and then increment the right pointer. All right. Now, we want to see if that word is in the word count hash map. If not word count dot contains key sub, if it's not in there, that's bad news. So current count, we're just going to clear it and start over. We're going to move the left pointer up to where the right pointer is, because everything before the right pointer is not usable. We're going to reset the total words to 0, and we're going to go to the right, this is, I don't know if this is going to fix it, but this is wrong. That should be less than or equal to. And okay, go one more time. Actually, let me check one more thing here. Add the left pointer. Yes. Okay. Well, you know what? Actually, that's a good time. Yeah, the first time I ran it timed out. Second time I ran it, the time was like, I don't know, way out here somewhere. But anyway, this is yeah. Give me an analysis of the complaints. This is O of n. Upgrade to analyze more. What? This is my analyzing rate limit. Upgrade to premium. No, I don't think so. I mean, it's like O of n. I think I set the other one up so it was like O of n squared, the way the window was sliding inside the window. But anyway, this is a good solution. Much faster. All right, so feel free to like, subscribe, and see you next time.